We are going to resume where we left off on Thursday with the blame Pope Gregory exercise. We're going to work on that one, and when we finish that one, I'm going to go and review some stuff from some of those extra problems from the back of the practice exam that you may not have seen. Some of the really tough problems from the back of the practice exam, or tougher ones. So to review, why are we blaming Pope Gregory the 13th? Because he commissioned the Gregorian calendar. So that is the standard civil calendar. Now, what we're trying to do is that we're trying to figure out, given a day, given any particular day, is that a valid date? Or so that means that the year is going to be fine. It doesn't really matter what the year is. Nobody, in terms of like, is that a valid year? If it's a number, it's a valid year, and we're not bothering to check are these numbers or not. Okay, but the months and days have to make sense, right? So the first thing we needed to do was ask the user, right, for the we had to ask the user for the day. Sorry, we had to ask the user what day it was. So please enter month, day, year. And what we did is that we used slice notation to figure that out. We used slice notation. So we got the first two characters and turned that into an integer. First two characters of date, 0 up to, but not including index 2, to get the month. Index 3, but up to, but not including 5, and then 6 all the way into the end for day and year respectively. So if we ask the user and we ask them to put it in and we say 04, 04, 40, 40, 0442, it'll say, okay, you've got April 4th, 442. Okay. So we've got our data now. Now to figure out if it is a valid date or not, we need to look at a few different things. So first off, we need to make sure that it's a valid date, right? Can't have a 13th date or a negative 7th date, right? Even though I could totally input those, right? So I could put in, let's call it Blenuary 92nd, 1446, right? I need to reject those on multiple grounds, right? The day, for one, is out of range for any day. All days either have 30, 31 days, or it's February, in which case it's its own messed up thing. Okay, otherwise, yes? Include what? This? Over here? So it goes up to, but doesn't include index 2. So it goes index 0 and 1. So index 0, index 1, up to but not include 2. Answer your question? Great. So here we've got these numbers. We need to reject them for some reason. So the question is, where in the world do we start? Well, first off, we shouldn't have to worry about if it's a leap year unless it's February 29th, right? So in other words, now let's just ignore the fact that leap years even exist. So what we have to do is figure out, okay, is it a valid month and is it a valid day? And we should start by working on one of those. Okay. So personally, now if you think about it for a second, you aren't going to know what is the valid range of dates until you know what month it is, right? So we have to figure out what month we're in first. So what we're going to do is we're going to use if statements to figure out if the month is 30 days, 31 days long, 30 days long, 31 days long, February, or invalid. Okay? So we're going to write ourselves an if-else statement. So let's go ahead and write an if statement to figure out if this particular month has 30 days in it. So let's go back for 1 second over to this one. September, April, June, and November, if you remember that, that rhyme, all have 30 days, right? So September, April, June, or November. So first, let's write an if statement. So if something, a Boolean statement, a true-false statement in between this colon to tell me whether or not this is, the month is currently April, June, September, or November. Right? That's for you to give it a shot at. So, all right. So, April. So first off, let's just simply detect if the month is April. To do that, we would say if month equals April, which is 4, right? April's the 4th month. If you typed this, you'd have to make sure you'd have a list of those things, of those dates. But remember, we're getting the date in a numerical format. So you're not too far off, but what we want is the numbers. We want to check so the other part of this is that we want to check if it's April or June or November or September. Now, that's the way we kind of mentally think of it. Oh, if it's April or if it's June. And so that leads to this very common mistake. If month is equal to 4 or 6 or 9 or 11, right? That's a very common mistake to have. I'm just going to top this off with a print statement. 30-day month. Just to kind of demonstrate a point here. Okay, so month is equal to 4 or 6 or 9 or 11. It feels like this should work, but it has some unexpected results, right? So if I run this and I put in 04/04/1997, oh, I accidentally hit a key while I was hitting enter. 04/04/1997. It's a 30-day month, right? Because it's, April. Next, let's go ahead and try this. 04, sorry, so let's go with 06, 01, 1999. It's going to say that's a 30-day month. But the issue is that we're trying things to confirm our beliefs. When you test something, you need to try to disprove your belief, prove that it doesn't work. So I'm going to try to prove that it doesn't work by saying that it is January 1st, 100.11. It says that that's a 30-day month. Now the reason this is happening is because Python has both true and false and truthy and falsy. What do I mean by that? Everything has everything can be used as a truth or false value in Python, unfortunately. It's a weird kind of thing, which leads to some nice, clean programming. But for instance, 1 is true, 2 is true. If it's evaluated as a true-false value, apple is true, false. The word false is also true. Basically, what it is that, so what in the world is false then? What has a falsiness of false besides obviously false, right? Well, these things do. Bool, 0 is false. Bool, 0.0, false. Bool, false. Basically, if it's a non-zero value, it's true, or it's truthy. And if it has a 0 value, such as being 0 or empty, then it's falsy. This is not necessarily something you should worry about. Especially, you don't have to worry about this for the exam. What it does do is that it leads to some code that in other languages would cause a syntax error to not cause a syntax error. So what this is saying is, if we're going to check first if month is 4. Okay, it's not equal to 4. Well, or 6. Oh, 6. Well, there's nothing else going on here, so I'm going to convert it into a true-false statement because there was an or. So this was truthy, so it becomes false or true. Make sense? So the way what we're actually looking for is if the month is April or the month is June, or the month is September, or the month is November. Make sense? That on how I added those things? How I've just added month is equal to these things? So we can do, okay, or, so we can do 1 1 1 1, sorry, 1 1, yeah, let's do 12 12 12 12, and it doesn't detect that's a 30-day month, whereas if I do 06 02 1987, it's a 30-day month, right? So that works. So that's how we can tell if it's a 30-day month. So what we'll do here is that we'll chain together a bunch of dependent if statements. So check if it's a 30-day month, else check if it's a 30-day month. So obviously the fill in is there to tell you to fill it in. Print. Then it's a 31-day month. Right? I'm putting that in for you to fill in the blank there. Else, if don't need to do it all caps. I just did that for no particular reason. And then finally, else. Okay, else. So if it's not a 30-day month, if it's not a 31-day month, and it's not February, that's all the possible dates it could be. So if it's not one of those, right, we do, then it's not between the range of 1 and 12, because between all three of these statements, we're going to have all the numbers 1 to 12 in here, right? So in that case, that's an invalid date. Print month is an invalid month. Make sense? So go ahead and take the time to fill in, and if you're not sure where to go, just follow this, right? These are for 30 days. So you just do the exact same thing, only you plug in the numbers for 31 days. Right, and there's going to be more than 4. So it might end up being a bit long if your text is as ginormous as mine is. So. And you don't have anything to add over here, by the way. That's just done, because it's the default kind of thing. All right, so let's go ahead and fill this in. I'm going to go ahead and just simply grab this, and we have 1, 2, 3, 4, 5. Sorry, we have 1, 2, 3, 4 months over here, 5 for February, so we need 7. 1, 2, 3, 4, 5, 6, 7, right? So let's go ahead and, while we're thinking about it, go ahead and do February. If month is equal to 2, February's done. Okay, if month is January, or February's down here, March, April's up there, May, June is up there, July, August, September, oh, there it is, November, sorry, October, and then November, and then December, right? So August, October, December. So let's just double check. I mean, I know I did it because I was going through and counting them as I was doing it. It's normally a good indication. 1, 2, 3, 4, 5, 6, 7, 8, 9, and then I know I wrote 10 and 12 over there, 11, 2. So now if we try any of these, we will get the respective value. So 11, so not 11, we've already tried that. 12, 12, 12, 12, sure, 22. It's a 31-day month. It ends up in there. Okay. Next we do 02, 07, 1998. 02 is February, so we end up in there. So we went ahead and we figured out, hey, is it a valid date, right? Now if we toss this out, we are going to get, sorry, if we toss this in, such as 45th day, sorry, 45th month, the 13th, 1999, it's going to say that 45 is an invalid month. Okay, so now that we know that, we need to check if it's a valid day. So inside, now one last thing to mention is that there's a reason why that these are ifs, that we do this as if, else, if, else, if, else. It's because they are interdependent if statements. If they are left independent, it's getting too far ahead of myself in my head. If they are independent, then we can that causes some issues, right? You'd think if it weren't for this else, it would be fine. So if I did, for instance, let's say it's May. Let's go ahead and say it's May. So 05, 11, 1990, and then slash 1990. There we go. It says 5/11. It's a 31-day month, and then 5 is an invalid month. Why did it say that 5 was an invalid month? Because it said it went, if this is true, no, it's not. If this is true, month is equal to 5, so this entire statement is true. Print out, it's a 31-day month. Then keep checking. If month is equal to 2, well, 5 isn't equal to 2. Oh, there's an else statement attached to this particular if statement. Make sense? So that if and else go together. So to make sure that basically only one thing ever fires, we do elif. We use elif if we want to make sure that these statements are connected with each other. Make sense? That's why we use elif there. So now that we're done with this, we need to work inside of each of these 3 functions. We don't have anything else to do over here, but we need to work, not functions, but inside of each of these 3 statements. First off, if it's a 30-day month, then what are the valid dates for a 30-day month? Right? 1, 2, 3, 4, 5, 6, all the way up through and including 30, right? So we should write now that we have this if statement, we can write another if statement in it and ask, okay, if it's between 1 and 30, great. But if it's not between 1 and 30, then there's an issue, right? So go ahead and write that. Yes? Sorry?
The code's not working properly for some reason.
Okay, I'll take a look at yours. But yeah, go ahead and get started on this. I'm writing that if statement inside the if statement. Checking what the date is. because you didn't turn them into integers. So surround those date statements with ints to turn them into integers, because what you were doing is you were checking, is it the word 12, is it the word 1, 2 versus the value 1, 2, or value 12, I should say. And now if you do that, that should work. Which I fixed only because I made that mistake a ton of times. Yeah, inside the inside the there, you're gonna write another if statement. Yeah, inside of the on statement, you have to write you want to check. I'll go through that later. Yeah. You have to check in the valve range. Right between 1 and 30. Good, but I mean, one because here it's between 1 and 30. This would be between 1 and 30. 1 and 30. This would be if it's between 1 and 28, or if it's 29, you need to check. Yeah. Yeah. That's why you put it up into months. Value error /2. So there's a few different ways to do this, depending on whether or not you want to print out it's a valid date or not. If you're just checking if it's invalid, you might do something like this. If it's, sorry, well, let's actually just go forward with this. Yeah, if a day is less than 1 or day is greater than 30, print print day is invalid for month, right? If it's less than 1 or if it's greater than 30 because it's a 30-day month. Else print valid date or something like that. But suppose we wanted to switch it up a bit because I want to show off something pretty cool in Python. Valid date. Okay? Well, suppose we flip it around the other way where the if statement, we check if it's a valid thing, and if it's not valid, we'll check if it's a, and if it's not valid, then obviously it's invalid, so we'll put the else in the bottom. So now let's go ahead and rewrite this. So how would I check if it's valid? If day is what? Greater than or equal to, it's greater than or equal to 1, right? If it's greater than or equal to 1 and its day is less than or equal to 30. Both of the ways I just showed are completely valid, right? Now what I like about Python, though, is that you can do things that you can't do in other languages. Things that make a lot more sense, that make it a lot more readable. For instance, this is, any statement like this, you can just simply flip it around by just flipping every part of this around. So instead it would be 1 day greater than or equal to 1 is the equivalent of saying 1 is less than or equal to day, right? So now everything's kind of going the same way. But what I like about Python is that in other programming languages, you need that and in between these two statements. In Python, you can write it like you would in math. If day is between 1 and 30. I really like that. That's really nice and concise. Make sense? So let's go ahead and run that and check 04/30 1992 is valid date. 04/31 1999, 31 is invalid for 4, right? 31, it's a 31-day month. So it's a 30-day month, so 31 is invalid, right? 31 was greater than 30, so it wasn't in the range, so it was false. Make sense to everybody here? This if statement makes sense. How it's indented inside of this, so it runs inside of this if statement. So if this is true, now check this statement, right? Now, I would say, oh, now let's work on now it's your turn to do this over here. But you want to know something? Super easy to do. Now that we've done it for here, we just simply copy and we paste and we switch all instances of 30 to 31, right? Because these are the days with the 31. Assuming I can type 31. Apparently that's difficult today. Okay, so month. So these are the 31-day months, so we'd print out as a 31-day month, and we just change that to 31. Okay. Next, finally, let's go ahead and copy this and paste it one more time for February. Now, except we have to do something a bit different here. So how many days does February have? Let's see, 28 days except on a leap year. So we always know, so let's just go ahead and just call and write Feb over here, February. So we always know, no matter if it's a leap year or even if it's not a leap year, right? Doesn't matter whether it's a leap year or not a leap year. If it's between 1 and 28, it's got to be a valid date. Make sense to everybody? Right? I don't have to bother caring about whether or not it's a leap year, right? So we'll write in order to handle a leap year, we're going to handle in one more statement, which is if day is equal to 29 and then I don't want to write a bunch of logic right in here. Like, it would get absurdly long to say, and year is divisible by 4, but not divisible by, but not divisible by 100, unless it's divisible by 400, right? Right? So in that case, what I'm going to do is I'm going to abstract this out. I'm going to say, and is leap year, and I just made up a function that takes in a year, right? I haven't written this yet. That's fine. I'm about to fix that. Is leap year, whoops, print validate, comma, leap year, right? Else if day is 29 and year is a leap year. Now that function doesn't exist right now, but as you can see, what I've done is I've taken this entire complicated logic of figuring out whether or not it's a leap year, and I've shoved it to the side for the future. The future happens to be now, but I've kind of shoved that aside. And the advantage of this is that I can have that there. I can go back up here and say, declare that function is leap year, which will take in a year. And just for right now, let's assume that I had more to code. Okay, let's assume that there was other stuff I wanted to code. I could just simply say return true. Every year's a leap year, sure, why not? And then I can just simply ignore the whole trying to solve if it's a leap year and continue on with coding, assuming I had more to do, right? Make sense? So the idea here is that if there's like this logical statement here, we can, or a bunch of code that needs to happen, you can abstract that away in a function and solve that function independently. You want to make one of the things that you will do as you get better at coding, or rather one of the things you should target doing as you're getting better at coding, is making your code modular, which you'll now be able to do much easier now that you're learning functions. What does that mean? It means breaking your program down into tiny little functions that can be called piecemeal, that basically these functions do one job, right? And this job is independent from the rest of the program. So you can so that way you can break every problem down into smaller problems. And if you need to, you can break those smaller problems into even tinier problems. Okay, so let's go ahead and actually just kind of test that. And so we haven't even finished the program yet, but I can test everything but the leap year. Like 02/28/1994 or 1996, which says February is a valid date. That's great. And then I can test it for, 02/31/1996. It's going to say, hey, it's invalid for February, right? 31 is invalid for February, right? The only date it's going to get wrong is that it's going to assume currently that everything is a leap year, but I can test everything around it, and that's the important thing. So now let's work on that last part, which is this is leap year function. So is leap year is going to return true or false, which means when we hit the return statement, it's going to say either return true or return false. Okay? If it does so, it's going to replace no matter what it hits, it's going to replace this highlighted portion with the value. It's going to replace the function call with either true or false, depending on what resolves. That's why we use functions and return values as opposed to just simply printing it out. If it printed it out, I wouldn't be able to replace it in my code. So first off, So there's a couple ways to go through the logic. I'm going to go through kind of the messy brute force logic, but there's ways to kind of make the logic a bit better, right? The logic I have written down is actually kind of the least helpful way to do it, which is that a year not divisible by 4 is a leap year. If it is divisible by 4, it's a leap year except for other possibilities. So first thing we'll do is check, is it a year divisible by 4? If year divided by 4, mod 4 equals 0. So if the year, when we divide by 4, has no remainder, that's what modulo does. If year divided by 4 equals 0, if there's no remainder after dividing it by 4, then it's possibly a leap year, right? So I'll just write maybe ... because I'll replace that in a second. Else, well, if it wasn't divisible by 4, then it's definitely not a leap year, so I'll return false. And again, there's a much more elegant way of doing this. If you go the other direction, check if it's divisible by 400 first. It's actually a lot cleaner. But I'm kind of going the way that you would go with this. Next, if it's divisible by 4, it's possibly a leap year, right? So we can, and rather than putting an and statement here, like if it's divisible by 4 and it's, something and so on, instead I'm going to break it down into another if statement. So next thing I want to check is it divisible by 100? If it's divisible by 4, if year is divisible by 100, right? If it's divisible by 100, that's also a maybe, unfortunately, because there's that exception of what if it's divisible by 400. But if it's divisible by 4 and not divisible by 100, that means it's a leap year, right? Divisible by 4, but not by 100. Everybody following my convoluted logic so far? Right? If it's divisible by 4 and not divisible by 100, right? If it's divisible by 4, and we check, if it's divisible by 4, we check if it's also divisible by 100. Oh, right, there was one other thing to it. Right, I forgot that. So if year divisible by 4, if year divisible by 100 equals 0, then it might be a leap year still. Yeah. Oh. Okay, sorry. Wait, no, not return false. What am I doing? If year is divisible by 4, I'm running on autopilot. That's what I'm doing. If year is divisible by 4, and if it's divisible by 100, it might not be a leap year. But if it's 4 and it's divisible and it's not divisible by 100, it's definitely a leap year. Sorry. See, this is why I say that this is hard, even if no matter how long you've been coding for, because you got to keep track of that logic. If the year is divisible by 100, that means it's possibly a leap year. If it's divisible by 400, the rules say if it's a leap year. Right? Everybody following so far? Else, if it's divisible by 4 and it's divisible by 100, but not by 400, return false. So we could simplify this. For instance, if year is divisible by 4 and year, and we can say and year is not divisible by 100, is not equal to 0, or I think that would work. If it's not divisible by, if year is not divisible by 100, or If it is, years divisible by 400, right? We could break it up into a line like that, but it gets messy, as you can see. Now, the other way to do it is to kind of go from the other way around and check, well, if the year is divisible by 400, and this one's elegant because it takes a lot of decision making out of your hands, which is if you go the other way. If year is divisible by 400, return true. If it's divisible by 400, it's leap year, right? Makes sense? Else if, sorry, not else if, but elif, year, I keep forgetting to put in the equal 0. I keep forgetting to put that in. Sorry. What is with my hands today? They are just missing keys all over the place. Equal to 0. If year mod 100 equal to 0. So what's going on over here with this other example? So we've done it one way, which is kind of just walking through the logic brutally. Then we kind of just simplified it. We took what we had over here, and we then did some knotting over there. Now, over here, we're saying, we're going the reverse direction. We're asking, if the number is divisible by 400, then yes, it's definitely a leap year. No ands, ifs, or buts. If it's divisible by 100, I'm just saying return false. Now, why is that? Well, I checked if it's divisible by 400 first. So if it's divisible by 100, but it wasn't divisible by 400, I've already checked if it's divisible by 400. So I get to say return false, because I've already checked the only way a 100 would be valid if it was a multiple 400. That makes sense to everybody? That just by ordering it this way, I kind of was able to get that check for free. Else, if year divided by 4 equals 0, return true. If it's divisible by, so if it's not divisible by 100, but it's divisible by 4, it's definitely a leap year, right? It's not a multiple of 100, then I don't have to worry about the other rules. Every 4 years is a leap year unless it's a multiple of 100. That's when the rules get complicated. And then if it's, then else, return false. So I'm going to go ahead and comment this part out. So there you have it. Slice 3 ways, I guess you can call it. If it's divisible by 400, yes. If it's divisible by 100, no. If it's divisible by 4, yes. And notice that again, yes, 100 is divisible by 4, but I'm checking if it's divisible by 100 first. If it's divisible by 100, it can't be a leap year unless it's divisible by 400, and I've already checked if it's divisible by 400. Right? I've done these by doing them in this order. Yes?
Wouldn't it be easier to make it just check if it's equal to 4 or divisible by 400 and 4 in one line?
If it's divisible by 400 and 4? If it's divisible by 400 and 4, yeah, that could probably work. That would probably work. I just like to walk through the logic kind of like this, especially in this kind of setting. Which is, again, readability helps here. 400 and 4. Yeah, well, if it's divisible by 400 and 4, that actually would, if I just did that, I'd have to have other checks, because in order, I'd have to have another, I'd still have to have this check over here to make sure. And the reason they're split up is because it makes the logic a lot simple. If it's divisible by 400, and it's divisible by 4, any number divisible by 400 is divisible by 4. So that second part of the statement would be redundant. So no, unfortunately, that wouldn't work there. Okay. So, all right, let's go ahead and test this out now. If I do 02 29 1996, it's going to tell me it's a valid date on a leap year. If I do 02 29 1997, it's going to say it's invalid. Okay, I'm going to copy that. Run. Now if I check 1990, now if I check 1900, it's going to tell me that's not a leap year. 29 is invalid for 2. Print. And then finally, let's try 2000, which, whoops, not 200, 2000, 2000, valid year. So let's go ahead and make that message a bit more explanatory. Invalid for month. And then year. And then I'm going to go ahead and save this, pause the recording. And so I just simply drop that on the server like I was saying here, or on the Discord server. If you need the code, of course you can, and you're not on the server, you can review the code from the video, right? So what you'll want to do with your code, by the way, at some point, turn it in over here in the in-class exercise Dropbox. So turn that in, right? So there should be a Dropbox over here in the in-class exercise for Blaine Pro Gregory, where you can find this assignment under Module 5. You'll be able to turn it in over there for in-class credit. So we're going to move on now to reviewing for the reviewing for the exam, because I know a lot of you are starting to get worried about that. But rather than going over the easy stuff, that's going to be on Thursday. Instead, I'm going to take the time to go over some of the harder stuff so that might help you on some of your assignments. Okay. Okay, here we go. And I'm still writing the exam tonight. I'll probably do what I've done for the paper exams in the past, which is notice that this is out of 105. Okay, 105. So the test will be worth 100 points, but there will be 105 points on the exam itself, meaning that you can miss 5 points and still get technically a perfect score. So that's just simply to build in a buffer for me changing the format of the exam from electronic to in-person. Right, so I'm going to go all the way down to the stuff that I've considered extra practice, and let's go ahead and try out something like I declare something like you should know what it is. But if you Google Project Euler Problem 1, you'll come up to it. Project Euler Problem 1. So Project Euler is this, or ProjectEuler.net is this wonderful website that has a bunch of math problems that need to be solved with programming. The first one especially is good for just kind of confirming that you know how a language works. There's other ones, though, that they get progressively more advanced as you go on, though. Like 2 and 3 are already a pretty heavy jump in terms of what you need to be able to do. 3, 5, 7, 5, 8. And if you've not done a problem, and if you create an account, you can actually check your answer by plugging in an answer. And if you've already solved it, like I have, it will have the answer for you. This one is very common. You can see that this very first one has a very common solution with almost 1 million people now have solved it. It's not too bad. So what is this problem anyway? So if we list all the natural numbers below 10 that are multiples of 3 or 5, we get 3, 5, 6, and 9, right? Those are all the natural numbers that are below 10, that are divisible by 3 or 5. Natural numbers are integers, but they're your counting integers, right? 1, 2, 3, 4, 5, 6, 7, 8. They're not negative numbers. That's kind of important, right? It's your counting numbers. So the ones we naturally use. That's the easy way to remember it. So if we list all the natural numbers below 10 that are multiples of 3 or 5, you get, well, 1's not a multiple, 2's not a multiple, 3 is a multiple of 3, 4 is not a multiple, 5 is a multiple of 5, 6 is a multiple of 3, 7 is not a multiple, 8 is not a multiple, 9 is a multiple of 3, and then if we went, and this was below 10, so that's why we didn't include 10, but if we kept going, 10 would be a multiple of 5. 15 would not get counted twice if we went all the way up to 15. It is a multiple of 3 and it is a multiple of 5, so that's included. So if we add up all these numbers that are multiples of 3 or 5, you get 23. 3 plus 5 plus 6 plus 9, right? How can I do that how can I do that without like even writing it down? Take the 5, break it down into 4 plus 1, 4 plus 6 is 10, 1 plus 9 is 10, and add 3 to that. So 23. Now find the sum of all multiples of 3 or 5 below 1,000. And you can imagine, you can figure this out on paper, but it would take forever. Like a good amount of time, an annoying amount of time. So instead, we'll write a program to do this for us. And what this one tests is for loop. It tests, hey, can you handle a for loop? And can you handle an if statement? Okay, let's go ahead and start exam 1 review. Okay. Of 3 or 5. And the math didn't copy because it's rendering, I think it's doing weird behind the scenes rendering of LaTeX, which makes it hard to copy. So there we go. All multiples of 3 or 5 below 1,000. Okay. So I'm just going to go and write this as a function because I can. Def Euler 1. And that just simply helps me keep this file clean so that I can have the code available, don't have to comment it out, but we can run it fairly easily. So to do all the multiples of 3 or 5 below 1,000, first off, we need a loop, right, to go through all the numbers. Okay, so we need to loop through all numbers less than 1,000 if number is divisible by 3 or 5, add it to our running sum, right? Running total. That's how. So when we're adding a bunch. Find the sum of all multiples of 3 or 5 below 1,000. That means that, again, we are just simply adding all these numbers together, getting one giant total. To do that, we want to do a running sum. To do a running sum, we set up a variable to hold all the values that we're adding together, which I like to call total. And then once we're done with it, we're going to print it out. So now that I've given you the pseudocode for this one, right, the outline for this code, go ahead and write that for yourself. And the indentations are where they are supposed to be. I mean, like relatively. You don't have to line up the number of numbers. In fact, I'm pretty sure I didn't hit it. I'm sorry, the right number of times. There we go. All right. So when you're facing big problems like that, as we'll see with the next one, don't think it's impossible. Think, okay, what part of this can I do? So looping through all the numbers less than 1,000. Okay? Well, I can do that. I know I can. For in range 1,000, right? That is all the numbers less than 1,000. And yes, technically that includes 0, but whatever. Next, what I can do is that I can say, can I print all the numbers between 1 and 1,000? I certainly can. So for num in range 1,000, print num. 1,000 is going to be pretty big, though, so let's go ahead and change that range to, 10 for right now, right? Right, we can always change it back to 1,000 in just a little bit, right? But we don't need it to be all the way for 1,000 at the moment. So, right? Okay, and let's go ahead and call this so we can test it. Euler 1. So all the numbers from 1 to 10. Great. And it printed out 0 at the end because it printed out total and total 0. Okay, so here's all the numbers 1 through 10. Can I add up all the numbers 1 through 10? Just all of the numbers. Doesn't matter if they're divisible by 5 or not. Can I add them all up? Yes, I can. And notice here I'm just kind of going through and just making the problem progressively more difficult until it's in line with the actual problem. Okay? Can I add up all the numbers from 1 to 10? Total plus equals number. And if you don't know this, how to do this by yet, this is where the indication that you really should be studying for the exam, right? So we add up all the numbers from 0 to 9. Sorry, from 0 up to and including 9, up to but not including 10. That gets me to 45. So now I can switch this back to 1,000, right? Because I'm not printing out everything, right? So all the numbers between 1 and 1,000, not including 1,000, adding them up, and I get a pretty big number. Okay? Now, let's only add numbers that are multiples of 3 or 5, right? Now let's add only numbers that are multiples of 3 or 5. Now I gave you this outline because, unfortunately, this isn't something you can fix just by modifying the range, modifying this over here. Instead, we will add that if statement. So if, and I know because I'm adding an if, and I only want to add it if the if is true, then I want to indent that into the if. So if the number is divisible by 3, just numbers divisible by 3. See, I've got a lower number, so that probably worked because that's only adding numbers divisible by 3. And then finally, if it's divisible by 3 or 5. Or, and remember, if you tried 3 or 5, then common mistake there, and you notice we go back up, right? Because that is always true. It's num. There's num divisible by 3 equals 0. Aha. Or num divided by 5 equals 0. Forgot the equals zeros. Yes. And so there we are. For num in range, if the number is divisible by 3, so for each number between 0 and 1,000, if the number is divisible by 3, or if it's divisible by 5, add it. Okay. And if we check our answer over here, we get that. Now the reason I wanted to do that first is because it shows the strategy I'll be using for solving one of these other ones over here that is really intense. We only have 10 minutes left, so I'll walk you through it, which is write a nested loop that prints out the following. 10, 8, 6, 4, 2, 0. Right? Let's go ahead and copy this so we know where we're going. Okay. Print out a nested loop that does the following. Okay. I'm going to do that as a function as well, just so I can separate that out. Nested right? So here what we're doing is we're printing out this number, and then without the 10, and without the 8, and then without the, all these things over here. So let's just go ahead and print out, I don't know, how many numbers do we start with? 6. So so there's 6 rows, and we start with 6 numbers. For I in range, let's go ahead and do rows. It's equal to 6. We know we have 6 rows. For each row in range, let's go with R. For R in range rows, let's see, if I just simply printed out 10, 8, 6, 4, 2, 0, that would be a lot. I can't just simply print that out. Well, I need a nested loop anyway. So for blank, so for C in range, let's see, we'll do columns as well. Right, we have rows and we have columns. Everybody see that? We have rows and columns. So this is a row, and the vertical split is the column. Range, column. And right now it doesn't matter what I'm doing. What matters is am I going to be printing out, am I printing it out correctly in like the right format? Here I'm just printing out marks. So print, so I don't need to print anything. I just call nested, and run it. And calls, plural. See, I make mistakes, plenty of them. And that's all one big line. Instead, I need them to be columns like that, right? So instead, what I need to do is I'm going to print out, I only want to print out 6 characters per line. So what I'm going to do is, like I said in homework 2, if you check the second page of the packet I give you, for lab 2, it tells you about, for lab 4 and 5, second page of that packet, it has this thing over here that tells you about modifying end. And then it all prints out on one line. And then finally, and what that does is that it says, normally when I print things, they're separated by new lines. Here, I don't want them separated by anything at all. And so we can say, okay, I can print this out and do that as a line, and when this for loop is done, what can I do? I can create a new line over here. And so now I've got a grid. Make sense so far? So I went from printing out one line to printing out one horizontal line, and then now by putting this print over here, when I say I'm done printing all the characters in a column, put this over here. Okay. Now I need to go and have less of these, right? I want to do one less each time. So for C in range of, and here's where it gets interesting. I need to shrink this down each time. Row starts at 0, R starts at 0, this starts at 6. And here we experiment. A lot of it is just experimenting and stumbling on a solution. But if you experiment long enough, you get this. Let's go ahead and add a space in. Why this? Well, what I needed to do is that this printed out 6 times. We always have 6 rows. That's not going to change. We're always going to have 6 rows. But what is going to change is how many columns. So there's a few ways I can go about this. Right now this says print out 6 columns, no matter what. But on the first row, I want 6. On the second row, I want 5. On the third row, I want 4, then 3, then 2, then 1. So, or another way to think about it, or the way you need to think about it to make the logical jump, is that we need 6 here, we need 6 minus 1 over here, 6 minus 2 over here, 6 minus 3 over here, 6 minus 4, and 6 minus 5. Make sense? So this value changes from 0, 1, 2, 3, 4, 5. Doesn't go up to 6, right? So instead, let's go ahead and just kind of show you what I mean by that. Columns from range 0. Another way to do this is subtract r. Why that? Instead of printing out x's, let me go ahead and show you r. I subtract 0 from columns, then 1, then 2, then 3, then 4, then 5. The reason we use variables is because they vary in their value. They change over time here. So now I've got this structure, right? I've got this structure. I might change this up a little bit, but now we need to start at the appropriate values, right? So here what we're doing in each row is that we're starting at 10 and we're subtracting 2, right? 10, we're starting at 10 and we're subtracting 2. So I'm going to start by playing around with this, right? 10, 10, 10, 10, 9, 9, 9, 9, 8, 8, 8, 8. So I'm not going to want to subtract r there because r changes based on what the row is, but not what the column is, right? If I instead play around with subtracting this, we get 10, 9, 8, 7, 6, 5, 10, 9, 8, 7, 6, 6, 10, 9, 8, 7, 10, 9, 8, 10, 9, 8, 10, 9, and 10. Which actually, if we take a look at the PDF, is close to that solution. We're getting close to that solution. But here we want to take away that starting value. So, what do we do? So in that case, we can say 10. Let's see. So first off, let's go ahead and solve that second problem, though, because we were so close to the solution on the second one. 10 minus c times 2. Rather than subtracting 1, we're going to subtract 2 each time. So how do we transform from this into this? 10, 8, 6, 5. So we start off at 10, then we start off at 8. So the number we start off at is going to change. So the number we start off at, let's go ahead and say our starting point. In fact, let's go ahead and solve that. Let's solve for that over here. The starting point for each of our for a row should be what? It's going to start at 10 for the first one. And then it's going to start at 10 minus 2, 10 minus 4, 10 minus 6, 10 minus 2. So 10 minus row. 10 minus row, and then let's go ahead and just print out the start. 10 minus row times 2. That making sense to everybody so far? 10 minus row times 2. The first row we subtract 0, the second row we subtract 2, the third row we subtract 3. If this is confusing for you, watch the video as I go through this in a less frenetic pattern because I'm running out of time here and I'm trying to get it done in our time limit. So finally, we have the starting point, start minus, and then within the column it needs to vary. So we take the column variable and play around with it and vary it. So we change what the starting location was. And again, there are multiple ways to do this one, right? Over here I did it like this earlier as well. Oh, no, that won't. Why? Because R. Oh, because, right, that doesn't start. Right. That won't work there because R changes and then it changes the value of what that is. but there are still multiple ways to do it like that. We know that this, but again, it's a matter of playing around with and understanding that these things vary, and it's kind of hard for me to take a step back and start from these from scratch here. But the idea here is, again, figure out how the row changes. Figure out how the column changes, right? The row changes by, for this one, the start of the row does not change. So all that changes for the row is how many things are printed out. For this one, the number of things in the row change, plus the number of things that are in, plus what the row starts at change. Another one that I recommend you trying if you're looking for another one, write a method that prints out the first n Fibonacci numbers. 1, 1, 2, 3, 5, 8, 13, 21. Fibonacci numbers, if you don't know what they are, look them up. They follow a pattern. Just simply, and it's a pretty good way of doing loops. All right, take care.